Okay, so section 6A, we're talking about characterizing data. So basically the math part of all this. So we're starting to talk about averages. So there are different ways to talk about average. The most common way we think of is what in math we call the mean. We have a mean here. Mean is just your normal average. You add everything up and divide by the total number you have. That's what most people think of when they think of average. But in math and statistics, there are two other ways we sometimes talk about the average, or a typical, a different way to describe the typical value of the data set. So other than mean, we have median. And this is just like it sounds, it's the middle. So median, middle value of the data set. Now you have to sort it between smallest to largest or largest to smallest, and then you take the very middle point, or if there's two middle values, it'd be halfway between the two middle values. Okay, we also have the mode. Now this isn't used very often. Every once in a while this will be used to describe it. This is going to be the most common value in a distribution. So when we talk about distributions, there are three different ways we can describe that. There's left skewed, right skewed, and symmetric. Symmetric just means that you have this middle value where the mode is equal to the mean, is equal to the median. And then you have the same number of values below it as you do above it. So if you were to graph it like a histogram, it would look like it's symmetrical, same on either side. Right skewed, you're going to have a tail over off to the right. And that means you have outliers. Outliers are just something that is outside of your normal data set. And we'll talk more about that here in a minute. Left skewed means you have a tail over on the left. So you have outliers, like really low outliers. And so you can see the mode is always going to be at the very top. That's going to be the most commonly found value. And then you can see how the outlier will affect the mean and median. Again, we'll talk about that more later as well. Okay. So example 1, let's find the mean, median, mode of the following data sets. So part A, we have body temperature in degrees Fahrenheit of randomly selected normal and healthy adults. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 values. So to find the mean, we're just going to add them all up. So we have 98.6 plus 98.4 plus another 98.6 plus another 98.4 plus 98 plus 98.4 plus another 98 plus another 98.4 plus 99 plus 98.6. Okay, so you add all those up and you get 984.4, and then you divide that sum by the total number that we had, which was 10, and we get 98.44. And in my math lab, it might tell you to round this to a certain decimal, so just make sure you follow that direction. Okay, so the mean is 98.44. Find the median, that means we have to sort these. So I'm going to try to list them in order, and I'm going to cross them off as I've listed them out. So it looks like the smallest numbers we have are 98, and we have two of them. 98.0, 98.0. And looks like the next one is going to be, looks like we have 98.4. We have another one. And another one. Another one. Okay, and then we have 98.6 here. Looks like two more. And then we have 99.0. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so the middle one, we have an even number. So we're actually going to have two middle values. 2, 3, 4, these two here are going to be middle values. Now these happen to be the same, so the middle number, or the middle of this, is just going to be 98.4. Now if these are two different numbers, we'd have to find the middle part of that. And to find the middle, you would just divide by 2. We'll see that in, or we'll see that process in part B. Okay, so for mode, we want the most commonly occurring number. So since it's all sorted out, it's going to make it easy. So 98.0, we have two of them. 98.4, there are 1, 2, 3, 4 of them. 98.6, there are 3, and 99.0, there's 1. So the most commonly one here is 98.4. Okay, so we see that actually all three of these are pretty even, which means this is more like a symmetric distribution because these are all the same, which means you don't have any outliers, which is nice, which is good. Okay, part B, we have the weights in pounds of randomly selected 50-pound bags of dog food. So of course it's 50 pounds, but it doesn't mean it's going to be exactly 50 pounds, right? So these are going to be the actual weights of some bags of dog food. So for me, we are going to add them all up. So I have 48.5 plus 49.6 plus 48.4 plus 49.9 plus 50.2 plus 50.3 plus 47.9 plus 48.3 plus 49.2 plus 49.8. Okay, so the total is 492.1. And there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 again. So divide by 10. And you get 49.21. So the mean here is a little bit less than this 50, which is what it's supposed to be. Okay, meaning we have to sort them. Okay, so it looks like the smallest number we have is this 47.9. Then after that, we have 48.4, 48.3 be the next lowest, and then 48.4. And then I have 48.5. And there's still 49, so 49, 6, 9, 2, and 8, so 2, 49.2. And then 49.6, 49.8, 49.9, 50.2, and 50.3. Now another thing here, if you have access to a computer while you're working on this, you can always put these in Excel, and then Excel can sort them for you and add it up and do all that quickly. But it's good to be able to do it by hand as well, right? Okay, so median would be the middle two numbers, 1, 2, 3, 4, 5. Okay, so these are the two middle numbers. So these are different now, so I need to find the middle of them. So to find the middle, I'm going to find the mean of these two numbers, because the mean is always going to give you the middle. At least of two values. Okay, so if you have two values, and the mean is the same thing as the middle, right? Because you're going to have symmetric, you just have the two values. Okay, so we do 49.2 plus 49.6 and divide by 2. So 49.2 plus 49.6 and then divide by 2, and I get 49.4. Yeah, so it's a little bit more than the mean here. Okay, mode. We have 1, 1, 1, 1, 1, 1, 1, 1. So in this case, there are no numbers that occur more than once. So we have no mode. Okay, so that's one weird thing about the mode is you can have none of it. You can have one, like we had here. You have one that was largest. Or sometimes you can have more than one mode. So if this had occurred 4 times and this one, then you would have 2 modes. Or if like even all 3 of these occurred 4 times and this one was just 1, then you would have 3 modes. Okay, so now let's talk about outliers. So an outlier is a value that doesn't quite fit into your data set. It's either going to be much higher or much lower than almost everything else. Now this outlier is going to pull the mean either up or down depending on where the outlier lies in the set. So if you think about it, so if I took this one and all of a sudden I put in like a 5, of course it's not, very realistic, but if I did put a 5, then this then would be like 989 and then divide by 11, and this number here is going to pull this mean down quite a bit because you're trying to find the average of all of these, and you got this tiny little thing out here that's going to mess things up. Now it doesn't really affect the median unless you have like more than one outlier. It may affect it more. But remember, the median is just the middle number, so it doesn't matter what the numbers are on the outside of the set. All that matters is the middle part of it. So like with this one, if I added a 5, the 5 would go down here, and the middle value would still be this 98.4. So it might move it up or down 1, or change it a little bit, but it's not going to really do anything at all. It also doesn't affect the mode because outliers are probably not going to occur very often, so it won't be the most occurring mode. So an outlier pretty much only affects the mean. So here's just an overall table comparing mean, median, mode. We have the definitions. The mean is the sum of all values divided by the total number. This is the most commonly used form of average. It always exists, whereas mode doesn't always exist. Mean takes every value into account. The median only cares about the middle numbers. The mode also only cares about the most frequently. Mean is the only one affected by outliers, and some of the advantages for mean, median, and mode. Median sometimes is used over mean if you have outliers because it might be more representative of the average, because it doesn't take into account that outlier. Okay, and the mode we most often use for qualitative data, when you can't have like a mean number, you just say, okay, well this is the most occurring values, this has got to be the most typical. Okay, let's look at another example with outliers. So here are cans of Coca-Cola, vary slightly in weight. Here are the measured weights of 7 cans in pounds. Okay, so the mean. If we add all these up, then I get a total of 5.6866. And there are 7 of them. So take 5.6866 divided by 7, and I get a mean of 0.8124. Okay, so for the median, so I gotta put these in order. So the 0.7901 is smallest, and then we have 8164, 16812, 0.8126, and then maybe the 8143, We have 816,819, so 61. 0.8165, running the room. And then we have 0.8176 and then 0.8194. Okay, so I got these in order. I have 7 of them, which means I do have a middle number. And that would be this one. So 3 on the left, on the right, so 0.8161 is going to be my median. Okay, so outlier. So do we have anything that just doesn't quite fit in like the other ones? Well, all of these start with 81. This one starts with 0.79, so this one's a little bit out of the norm. So this 0.7901 is your outlier. And see, we see that this mean is going kind of pulled down to the 8.24, which is actually lower than all of my other values. So that makes it kind of weird that the the average is less than most of them, all but one. So let's look at the mean without the outlier. So if I ignore that one and I just add these 6 up, then I have a total of 4.8965, and now I only have 6. So I divide this and I get 0.8161, which seems like it's much more descriptive of this data set. The median without the outlier, now we have 6. So now I have 2 middle numbers, 0.8161 and 0.8165. So we get the middle of it, and you can add these two together or divide by 2, or if you just think you have to go from 1 to 5, the middle number is 3. So 0.8163. If you can't see that, then you would just add 0.8161 plus 0.8165 and divide by 2. Okay, so we see here that the mean and the median were pulled a lot closer together than they were before. Okay, so now you can pause the video and try to do this one on your own, and then come back and check your work. So here we have margin of victory in the Super Bowl for 2003 to 2017. Okay, so the mean. We're going to add all of these up, and you should get a total of 149. Then we have 3, 6, 9, 10, 11, 12, 13, 14, 15 numbers here. So 149 divided by 15, and we get 9.9. To find the median, we put them in order. So I start with 3, so 1, 2, 3, 4 3s. And then I have 3 4s. Then I have 2 6s. And 11 and a 12. 2 14s. 27 and 35. Okay, so because we have 15, the middle number is going to be the 8th one. 2, 3, 4, 5, 6, 7, 8. Just double check. We have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Same on both sides, which means this is the middle. Our median is 6. Now, do we have any outliers? Well, we have these here, which are, it does jump up a little bit here, but then we have several in this range. But then it jumps up to 27 and 35. Well, those are like way different, and there's only one of those. So you can say that we have 2 outliers, a 27 and a 35. You know, most Super Bowls aren't going to have that big of a difference in their final scores. Like this is like what, 2 touchdowns? So these are much more likely, and these are not. So these are my 2 outliers. So let's ignore these and find the mean now. So if we take all those out and we just add up the other 13, then we have a total of 6.7. No, we don't. We have, sorry, I'm looking at the wrong thing. We have a total of 87. and then we divide that by the 13 we now have, and we get 6.7 for our new mean. Okay, for the median, now we only have 13, which divided by 2 is 6.5, so that would mean the 7th one is going to be our new median. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so our median here is 4 in this case. So right now, for before, our mean and median were almost 4 apart. Now they're 2.7, so they're a lot closer together now. Okay, average confusion. So when we use the term average in everyday life, sometimes it can be a little bit confusing. Like I said, most times we're talking about the mean, but sometimes the median is actually a better way to describe the typical data set. So let's talk about Dunder Mifflin, right? So in the office, we look at the salaries for these employees. So Pam, Kevin, and Angela all get $25,000. Andy and Dwight get $100,000. Jim gets $200,000, and Michael gets $300,000. Well, if we find the median here is $100,000, which looks pretty good, right? The mean salary also looks pretty good. It's $110,000. But the mode salary is $25,000. So most people get $25,000. So, that's quite a bit. So depending on what you look at for average, can make a difference. So, it looks good that the median is 100,000, but that's because you have several who are above that, but most of them are going to be below. Okay, something else we can use for average is what's called weighted means. So we actually see these a lot, especially in school, because this is what we do for grades. So far, every number that we've used to find an average, to find a mean, has had the same weight, which means, a 5 is just a 5. It doesn't really matter. It's the 5 in one thing is going to be the same thing as a 5 in something else. But with weighted means, some values make a bigger difference on the overall thing. So, for example, your grades, where your tests, all of your tests are going to have a different weight than, let's say, your homework. And the final especially is going to have more weight than each individual test, right? So I had to start here just to remind me that this is not your actual grade percentages, because I use this for different ones and sometimes it has a different percentage. So this is just a sample percentage for a graph, for a class. So let's say your test average is worth 35% of your grade, your finals worth 20%, your homework average is worth 30%, and your project average is worth 15%, which means you have to do a little bit of math before you can figure out what your course grade is. You can't just take the average and you can't take like all 4 of these and average those 4 to find your course average, because they don't all weight the same. So because your test is worth 35%, you're going to end up saying 35% times, right? And math means times. So 35% times your test average, 20% times your final, 30% times your homework, 15% times your project average, and then you're going to add all 4 of those together. Note that we can, let's say they were all worth 25%. If so, if everything was worth 25%, then you'd have 25% of your tests, 25% of your homework, 25% of your final, and 25% of projects. So here you're multiplying everything by 25%. In math, when you have a common thing in each term, you can factor it out. So this would be 25% times your test, plus your homework, plus your final, plus your project. right? And 25% is 1/4, right? So this is the same thing as t plus h plus f plus p divided by 4, which is your normal mean. So when everything's weighted the same, that is just your normal mean. But when things are different, you actually have to keep these separate, like this. Okay, so let's look at an example. Say Thomas is taking Math 143, and this is the weight for his class. His test average is 52.7. His homework average is 85.24. His project average is 30, and his final average is 43. Okay, so what is Thomas's overall score for the class? Okay, so you can take 35% of his test average, which is 52.7, and 20% of the final. So 20% of 43. This final is 43. And you have 30% of homework. His homework is 85.24. And 15% is his project, which is 30. Okay, so I do 0.35 times 52.7 plus 0.2 times 43 plus 0.3 times 85.24 plus 0.15 times 30. And we get 57.117. This is a percent. So his grade overall in the class is 57.117, which is an F. Right, so if this looks like your grades, you are in trouble. Right? So come see me before this happens and we'll get it all sorted out. Okay, so right now he has a F, but he wants to get a B in the class, which requires an overall score of 80 or higher to get a B. So what must you score in the final exam to get a B, a C, a D, or an A? Okay, so he wants to figure out for each one. Okay, so now we're saying we don't know what this final is. So we can plug in everything else though. So we know his test average is still 52.7. So we still do 30.35 times 52.7. 20% of his final. This one we don't know, so I'm just going to put an X. Because that's what's great about math is we can just say, okay, I don't know what this is, so I'm just going to put a placeholder there in which we use as variables. Okay, and then there's 30% of his homework, which is still 85.24. And 15% of his project is 30. Okay, so this is what you would do to figure out the his overall grade. Now, I'm going to simplify this to make it a little bit easier to work with because I can do this multiplication, I can do this multiplication, and then I can add all three of those together. So I'm going to go ahead and do that. So 0.35 times 52.7 plus 0.3 times 85.24 plus 0.15 times 30. Okay, so I get 48.517. Okay, so this is the calculation I would need to get his overall grade. Now, I want to know what this X has to be to get a particular score. So what I'm going to do is I'm going to set up an equation, 48.517 plus 0.2x, and I want that to equal a certain amount. So I want that to equal an 80%. So all of these I'm keeping as the whole number, so here I have 80. So then I solve for x. I'm going to subtract 48.517 from both sides. So I have 80 minus 48.517. I get 31.483. And then to get the x, I'm going to divide both sides by 0.2. and I get 157.415. So he would have to get 157% on his final, which of course is not possible. So it is not possible for him to get a B in this class, which is kind of sad, but that's how it is. Okay, so knowing this, if you wanted to get an A, you'd have to get even higher than that, right? So the only difference here is that it would be equal to 90 instead of 80. So then we'd have 0.2x equals 90 minus the 48.517. So it'd be 41.483. Divide both sides by 0.2. And we get 207.415, which is even crazier than that, right? Okay, so we can't get an A or B, but can he get a C? So he has to get at least a 70 to get a C. So then we take the 70 minus the 48.517, and we get 21.483. Divide both sides by 0.2. We get 107.415. So again, it's not possible for him to get a D either, or a C. But can he get a D? So this is equal to 60 instead of 80. We have 60 minus 48.517. So 0.2x is going to equal 11.483. Divide both sides by -2. We get 57.415. So it is possible for him to get a D. So he can pass, technically, but only with a D, not with an F. So instead of getting the 43, he'd have to get a 57. Okay, another example. Ryan is taking an advanced psychology class in which the midterm and final exams are worth 35% each, and homework is worth 30% of the final grade. On a 100-point scale, his midterm exam score was 85.5, his homework average score was 94.1, and his final exam score was 88.5. So on a 100-point scale, what is Ryan's overall average for the class? Okay, go ahead and try this on your own, and then come back and see if you got it right. Okay, so the overall average. So you have the midterm and final are 35%. So you have 0.35 times your midterm and 0.35 times your final. Okay, the homeworks were 30% of the final grade. So if we add all this together, this would be 70% and 30%. That's the entire thing. So this will give you your overall grade. Okay, so we have 0.35 times your midterm. The midterm was 85.5. And then 35% on the final, which was, the final was 88.5. And 30% on homework, which is 94.1. Okay, so you plug everything in there, and you would end up with an 89.13. So his overall grade is a B. Okay, Ryan was hoping to get an A in the class, which requires an overall score of 93.5 or higher. Could he have scored high enough on the final exam to get an A in the class? So we're going to do something similar to this. We know his midterm. We're going to keep his midterm at 85.5. And 35% of the final, which we don't know. We're going to see if, what we'd have to do to get an A in the class. And then homework is still 94.1. So simplifying this, 0.35 times 85.5 plus 0.3 times 94.1. And we get a 58.155. Okay, so I want to get an A. So I'm going to take 58.155 plus 0.35x and set that equal to 93.5, because in this particular class, that's what he has to get. Subtract the 58.155 from both sides. And I get a 35.345. Divide both sides by 0.35. And I get a 100.986. So unfortunately, no. He can't get an A on the class. He'd have to get just over 100. So if one of these was a little bit higher, it might have been possible. But as is, he cannot score enough to get an A on the class. Okay, something else that students come across a lot is GPA. So your GPA stands for grade point average. This is a weighted average, and it's a scale from 0 to 4, where an A is a 4.0, B is 3.0, C is 2.0, D is 1.0, and F is a 0. So depending on the grade you get in the class, that's how many points you get. Incompletes and withdrawals don't give grade points, so you don't influence GPA. Also, pass-fail classes don't influence your GPA as well. So to get your GPA, you want to get the total grade points divided by the total credit hours. So you add up all the points you get divided by the total number of hours. So let's say Math 143 is worth 3 credits and you get an A in it. So to get the grade points, you're going to multiply the number of credits times the weight you get from the grade. So this would be 3 times, an A is 4 points. So you get 12 grade points for that class. For this Religion 211, it's 3 credits, and a B is worth 3 points. So you get 9 grade points here. Spanish gives you 4 credits, and a B gives you 3 points, so it would be 12 grade points. This Chem 135, you have 3 credits, and a B gives you 3 points, so that's 9 grade points. The Chem 135A gives you one credit, and A gives you 4 points. You get 4 grade points. So total, you have 12, then 21, 33, 40, and 44. So you have 44 grade points overall. Or no, did I do that wrong? Let's see, 13, 15, 17, I did. This is 46. 12, 21, 33. Oh yeah, 33, and this would be 42, 46. Okay. So we have 46 grade points. Total credits is 3, 6, 10, 13, 14. So 46 credits, 46 points for 14 credits. So your GPA for this semester will be 46 over 14, which is 3.29. Okay, so remember, this is just for this semester. Now, when you get to another semester, you would add on that semester's points to this 46, and then that number of credits to this one, and then you would find a new GPA. You can't just find the GPAs for the 2 different semesters. So let's say the next semester, you take 12 credits, and you get, that's what, like 4 classes. Let's say you get a B on all of them. Which means you would have, what, 36 points? So GPA for this semester would be 36 points divided by 12, which is a 3.0. Now you can't just average these two together because you have different number of credits here. So this actually weighs more than this one. So what we have to do to find the overall GPA is add the total number of points, so 46 plus 36, and add together the number of credits. This would be 7882 over 26. To get a 3.15. And that would be your overall GPA. If we just try to do this, 3.29 plus 3 divided by 2, this would give you 3.145. So I mean, it's close just because we have 14 and 12. But the more semesters you add on, the bigger difference it'll be. So let's be cautious about that. Okay, last example is another GPA problem. So a student has completed the 15 credits in the table below during one semester. Grades are weighted as follows. In this case, the pluses and minuses will make a difference. So an A is 4, A minus is 3.7, B plus is 3.4, B is 3, B minus is 2.7, C plus is 2.4, and C is 2. Okay, so for statistics, it was 4 credits, a grade of A, which gives 4 points, instead of 16 grade points. 3 credits and a B plus gives you 3.4. So that is 10.2. French is 4 credits, and a C plus gives you a 2.4, so that's 9.6 grade points. This is 3 credits, and a B minus gives you 2.7, so that's 8.1 grade points, and this is 1 credit for GeoLab, and an A minus gives you 3.7, so it's a 3.7 grade points. Okay, so if we total all the grade points, add everything up here, we end up getting a 47.6. Add up all the credits here, and we have 15. Just to confirm, that's what they said here. So the GPA, you're going to take the grade point and divide it by the total number of credits. So we get 3.17. Okay, so here you can think of this like a weighted average, where the number of credits, so like this A has more weight than this B plus, and like this B plus has more weight than this A minus here because it has more credits. Okay, so it's just one application of what it means. So the GPA for the semester is 3.17. So what grade would the student need in French to raise her GPA over 3.5? Okay, so let's say this isn't done with and she can get this grade up, and she wants to have a GPA of 3.5. So just like before, we're going to now insert an X in here. So statistics, we have 16. Eastern religions, we have 10.2 grade points. For French, we don't know what the grade is yet, so I'm just going to say it's 4 times whatever grade we get in French. Geology we got 8.1 grade points, and GeoLab we got 3.7 grade points. And to find the GPA, we add up all the grade points and divide by the number of credits, which is 15. We want that to equal 3.5. So I'm going to go ahead and simplify the top. So we have 16 plus 10.2 plus 8.1 plus 3.7. So we have 38 plus 4x over 15 equals 3.5. Okay, so now we want to solve for x. So x is in the numerator, which means we have to get rid of the denominator. So I'm going to multiply both sides by 15. So 38 plus 4x is equal to 52.5. So solve for x, we're going to subtract 38 from both sides. So we have 4x equals 14.5. So for French, we need to get this 14.5 grade points. Figure out what the grade is, divide both sides by 4. And we get a 3.625. Okay, so we need the grade to be worth at least 3.625. So 3.625, which means we'd have to have an A minus. That was it for 6A.